All right, hey guys. So we have R and S, and there are two regions enclosed by the graphs of f of x and g of x. And if you're not sure which curve is which, you have a calculator to be able to plug this in. But the curve that looks exponential, that's your f of x. All right, and then the other curve is the quartic curve polynomial. That's this one right here. That is, this is g of x. Okay, so find the sum of the areas of regions R and S. So you want to put a vertical rectangle in the strip. All right, it's a vertical rectangle for both. So both of these are in terms of x. So you're doing top curve minus bottom curve. So you're going to end up doing g of x minus f of x for the first one. And you're going from this point of intersection, which is 0, to this point right here, which you have to find on your calculator. That point is 1.033. All right, and you're adding it to the area of region S. So region S goes from 1.033 to this point of intersection, which is 2. And top curve minus bottom curve would be f of x minus g of x. All right, and this answer ends up being 2.004. All right, so that's how you find the area, that region. Part B, region S is the base of the solid whose cross sections perpendicular to the x-axis are squares. So, all right, find the volume of the solid. So it looks like we're just using region S, and that's the base, and the cross sections perpendicular to the x-axis are squares. So I'm going to try to draw it on here. Like I said, it's not easy drawing it three-dimensionally, but the cross sections are perpendicular to the x-axis. So these squares, all right, it's kind of hard to see, but that square, I try to make it look three-dimensionally where this top is sticking out of the page. All right, so this is the height, and this is the width, and this is the top of it sticking out of the page. So the volume is the area of the face, which is side squared. The length of the side is top curve, which is f of x, minus the bottom curve, which is g of x. And you're taking that side and you're squaring it. Okay. And then we really should have dx in here, and I should have put them up here too. Okay. So, and the bounds go from this point of intersection, which you already determined is 1.033, and the other point is 2. And when we do that, we're going to get 1.283. 1.283. All right, and last but not least, let h be the vertical distance between the graphs of f and g in region S. Find the rate at which h changes with respect to x. Whenever something is a rate, that's a derivative. So let's write out the equation for h. So h of x is going to be top curve minus bottom curve. So in region S, the top curve is f of x. So it's f of x minus the bottom curve, which is g of x. And then we want to know the rate of change of h. So we're looking at the derivative. Well, it's not like we have to do anything crazy with this derivative. It's not like it's chain rule or product rule or quotient rule. We're literally just taking the derivative of each one. So f of x, f prime of x minus g prime of x. And we want to evaluate it when x is 1.8. So thankfully you have your calculator for this. So I'm going to move this down. And we have our calculator for this. So we're literally doing h prime of 1.8. So we're plugging 1.8 in here and here. So f prime of 1.8 minus g prime of 1.8. And you end up getting negative 3.812. Now, don't forget, there's an easy way to find a derivative at a point in your calculator. I want you to try this. All right, in your calculator, I want you to hit menu 4, 1. That's numerical derivative at a point. It'll come up as the variable, which should be x. The value is 1.8. You want it to be the first derivative. Hit OK. And you got to plug the function that you want to take the derivative of in. So that means you got to plug in f, that equation from above, and then do the same thing, plug in g, that equation from above. All right, so you should be trying that. Menu 4, 1, menu calculus numerical derivative at a point. It sets up the template for you. All right, so play around with that, because no way do we want to make it harder for ourselves and try to derive this by hand. We can. But if this is a calculator question on my exam or the AP exam, why are you wasting your time when your calculator can do it for you? So you definitely want to be resourceful and think about how to quicken things up. All right, hope this helped.